Okay, now that we got that out of the way, let's talk about the SMB beacon. The SMB beacon is a beacon that links to a parent beacon and receives all of its tasks from the parent beacon and sends all of its output through the parent beacon. Okay? It's called the SMB beacon because this linking peer-to-peer happens over a named pipe. A named pipe is a Windows interprocess communication mechanism that allows two programs to communicate with each other like they're reading from and writing to a file. Now, the named pipe beacon is called the SMB beacon because you can do this interprocess communication not just process to process on the same host, you can do it process to process on different hosts as well. And when you communicate host to host this way, that traffic is wrapped in the SMB protocol, okay? Here's what that looks like in Wireshark. You can see the read and write primitives for our named pipe communication. Now, let's talk about the staging process for the SMB beacon. The payload name for the SMB beacon is Windows Beacon SMB Bind Pipe, okay? Now, what I'm about to explain is transparent to you, but you should be aware it's happening. When you use the SMB beacon with a local Cobalt Strike action, for example, if you use the SMB beacon with a privilege escalation exploit inside a beacon, which affects localhost, the SMB beacon will stage differently than it will if you're attacking a remote target. When you target something on the localhost, the SMB beacon will use a bind TCP stager. This is a small piece of code that creates a listening socket bound to localhost on the target system. The beacon that's responsible for staging the payload will connect to that socket, deliver the SMB beacon, and the stager will inject it into memory. On a local host, I staged the SMB beacon this way to avoid any permission issues when you're doing privilege escalation, okay? Because pipes do have permissions associated with them. Now, if you're using the SMB beacon to deliver a beacon to a remote target, then Cobalt Strike will use the named pipe stager. The named pipe stager runs on the target and it binds to a named pipe for staging only, okay? The beacon that is responsible for staging that payload will connect to that named pipe, deliver the beacon, and the named pipe stager will inject it into memory, and that pipe will shut down, and then the beacon communication will continue as normal. So the big thing here is be aware that there are two different staging processes happening. Now, when you configure the SMB beacon, just like before, the listener dialog is where you're really configuring the staging process. Because the SMB beacon stages over a bind TCP or bind pipe stager, the host piece has no play here. The port does matter. Do not set the port to port 445. Just set it to some random number. That is the port that the bind TCP stager will bind to, okay? That same number will also factor into the pipe name that is used when you put the named pipe stager on a remote target. Now, here's another thing to know about the SMB beacon. You can link to the SMB beacon if Cobalt Strike doesn't do it for you using the link command. Just type link in a beacon console and the address of the beacon you want to link to, okay? If you want to unlink from a beacon, just type unlink and the address of the beacon you want to unlink from, okay? Once you unlink from a beacon, that does not mean that it goes away. The beacon is still running. You may use the link command, even from another beacon, to link to it. Also, you may chain SMB beacons arbitrarily deep. Now, when you use the link command, be aware that you may encounter a few different errors, and I want to explain what these are. When you get an error from a beacon command that's a number, it's usually a number reported by the getLastError function in the Microsoft Windows API, okay? If you go search for MSDN error codes and the error number, you'll be able to find more about what the error actually means. But here's a few you might see. Error code 2 is file not found. And in the case of link, it means there is no beacon for you to link to, okay? Whatever process you used to get an SMB beacon on a target failed. Error code 5 means access denied. That might mean you don't have permission to connect to that pipe, or your credentials are invalid. Error code 53 is bad net path, and that means you have no trust relationship with the target system. Bad net path most commonly occurs when you try to use the link command running from a system context to link to a beacon on another system. The way to correct it is to establish a trust relationship as any user with the system you want to link to. Okay, let's take a look at the SMB beacon. For this demo, we're going to work from my local host team server. And you can see I've taken this What a Hog beacon and set it to beacon back every 5 seconds, okay? So now we've got a beacon to work through. Let's go ahead and create a SMB beacon listener. Let's go to these little headphones and let's press add and create Windows Beacon SMB. We'll call it Beacon SMB and let's give this value here, which will go into the pipe name, and press save. And there we go. We now have an SMB beacon listener. The SMB beacon listener is really useful for things like privilege escalation and lateral movement. And we'll see both of those later in this course. But for now, let me show you what I mean by that. I'm going to use an attack called bypass UAC, which we'll explain later when we talk about privilege escalation. And I'm going to target the Beacon SMB listener with this particular attack, okay? Basically, what this attack is going to do is give me a new beacon that is running with elevated writes in certain situations. And what you can see is we get a new beacon that is linked through this parent beacon, okay? So this beacon, What a Hog, is What a Hog star. The star means administrator level writes. The chain here means it's linked through the address referenced here, okay? And if you see red with lightning bolts in the session views, that means an elevated context. Cool. Now, why don't we inject an SMB beacon into a system process? Let's go pull a process list real quick. And let's find something running a system that looks kind of cool. Why not VMtools D? So we'll inject into this system level process and we'll inject an SMB beacon, okay? This is another action or another example of targeting a local host process or local host only action with the SMB beacon. So now we have another beacon that's chained through this beacon, which is egressing through this beacon. So now we're kind of pivoting or chaining 2 levels deep on the same system, okay? Now it can get really confusing when you're moving around a system or even a network by chaining multiple levels deep. It can be really hard to keep track of those chains in this view. This is why we have the pivot graph. If we come over here to show sessions in pivot graph, you can see that Cobalt Strike will visualize the SMB beacon chain for us. Now it's a lot clearer. Here we see our initial foothold. We see our initial privilege escalation, so the beacon that gets us into an elevated context. And we see the beacon that we injected into a system level process. Pretty cool, right? So that's an example of visualizing the beacon chain. Now, I mentioned before that you can also use the SMB beacon to control systems host to host. Let me show you what that looks like. Let's come over here and interact. And we're going to take a system that I happen to know I am an administrator on, and that system's called Granite. And we're going to talk more about PSExec PowerShell and Friends in the lateral movement lecture. But let's just do PSExec PowerShell, Granite, local beacon SMB. And this is going to stage a SMB beacon over a named pipe. And there we go. We now have control of this other system, and it's chained through this one. Okay? Cool. Now, let's say I don't want to control this system anymore. Well, we can de-link this SMB beacon. Let me show you how. We just do unlink and give it the address of the beacon we want to unlink. So this is the IP address of Granite, and there you can see it's disconnected. Okay? Cool. Later, you can use the link command to assume control of an SMB beacon from elsewhere. So here, we're going to link to Granite. Okay? So this beacon is going to try to assume control of Granite, and there you can see our pivot graph reflecting the new communication path for this beacon. So the SMB beacon is a very flexible tool to let you pivot process to process on the same host, or pivot host to host by chaining beacons together. Okay, now that we've learned all there is to know about the SMB beacon, let's go into a pretty important topic. Cobalt Strike is designed for long-term operations from internet-based infrastructure. Okay? That means it's designed to have compromised systems call back to your system at random places on the internet. Now, one of the things that factors into that is payload security. Your customers may want to know, and hopefully you want to know, what happens if somebody tries to get in the middle of the communication between my compromised network and my Cobalt Strike team server. What happens if somebody takes over one of my redirectors? Will they be able to take over my beacon? And the answer is no. I want to talk about some of the security features in beacon. First, the beacon stage, the payload running on the target, does take steps to authenticate the team server. Next, beacon tasks and beacon output are encrypted. Next, beacon does have replay protection for tasks, okay? Finally, one thing to note is that all of the above applies to the beacon payload once it is staged. The payload stagers, due to their small size, do not have security features. So, how does the payload security in beacon work? When you stand up a team server and define your first beacon listener, the team server will generate a random public-private key pair for that team server. Okay? When the payload is staged, the public key for that team server is shipped with the beacon stage. Once the beacon stage decides to communicate with you, what it is going to do is first send metadata about the beacon session, okay? That metadata is going to contain information like the user the beacon is running as, the process ID it's running in, the computer name you're on, and the internal IP address of that system as well, okay? The metadata also contains a random session key that the beacon stage generated on the target. The session key is unique to that particular beacon session. Now, to send that session key back to the Cobalt Strike team server, the beacon stage encrypts the metadata with the team server's public key. That means only the Cobalt Strike team server can decrypt that metadata because only the team server has the private key that corresponds with that public key. Now, when Beacon downloads tasks from the team server, the team server is going to encrypt those tasks with that beacon session's session key, okay? And likewise, the beacon stage is going to decrypt those tasks with its session key as well. Same goes for output. When the beacon stage sends output back to Cobalt Strike, it is going to encrypt the output with the session key, and the team server is going to decrypt the output with its session key. So that's how the payload security mechanisms in Cobalt Strike work. One thing to keep in mind is that these mechanisms, I can't say it enough, they apply for the DNS beacon, the HTTP beacon, the SMB beacon, and all future beacons to follow. So, in this lecture, we talked about listener management. We talked about the HTTP and HTTPS beacon. I took you through the DNS beacon. We also talked about the named pipe beacon. Finally, we concluded this lecture by talking about payload security. This concludes part 2 of Advanced Threat Tactics.